All right, so for this video, we're going to be going over 2.4, which is talking about symmetry, okay? I ended up not getting those Sharpies, but I will upload the printout of this and you can follow along. But I think the video is a lot clearer this time. Okay, so we can either be symmetric with respect to the x-axis, the y-axis, and or the origin. So we can write definitions real quick. So definition, let's say symmetric with respect to the x-axis. Okay. So we do this by replacing your y with a negative y, okay? And basically it should produce an equivalent equation, and we'll look at an example soon. So you should get the same equation when you do that, okay? So that's the first one. And then we have symmetric with respect to the y-axis, okay? And I'm sure you guys can guess what that is. So we're going to be replacing our x with negative x, and it's going to give us the same equation, okay? And last, we have symmetric with respect to the origin, okay? And this would be with both. So we're replacing our x and y with negative x and negative y respectively, right? And it's still going to give us the same equation. All right, so let's go ahead and look at the first example. Example 1. So we have y is equal to x squared plus 2. And we want to know if that's going to be symmetric with respect to the x-axis, the y-axis, and or the origin. So we're going to check all three of them, okay? So let's do the x-axis first, okay? So that means we're going to replace all of our y's with negative y's. So I'm going to go in here and I'm going to change this y right here to a negative y. And I'm going to leave everything else the same. And now the question is, are these two equations the same? Do they look exactly the same? They don't, okay? So this one would be a no, okay? Now let's do it for the y-axis. Okay, for the y-axis, we change all of our x's to negative x, right? So our y is going to stay the same, and then our x is going to become negative x, okay? When you're plugging these in, you always want to make sure that you use parentheses. So you don't want to just add the negative in the front. Your x becomes negative x, so it's kind of like plugging in negative x for x. So you should always use parentheses when you're doing that, okay? If you want, I'll go ahead and add parentheses here. We can just make that something that we always do, okay? So if we simplify this here, negative x squared is negative x times negative x, right? Which is going to give us a positive x squared. And then we look, do these two equations line up? And they do. So this would be symmetric with respect to the y-axis, okay? So this is a yes. And then last, we can check the origin. Okay, so for the origin, we change both the y and the x. So this first one's going to be negative y equal to, I'm going to change it to a negative x squared plus 2, okay? So this negative y is still going to stay a negative y. This negative x squared is now going to become a positive x squared, right? And then plus 2, okay? So the question is it the same as the original equation? And it's not. So this would be a no. All right, there's also another way to look at these. We can look at the graph. So if we're looking at this on a graph, we know that x squared is going to make a U shape, a parabola, right? Pointing up since it's positive. And then this positive 2 on the outside is going to raise it up 2 places. So we're going to have a graph that looks like this, okay? Now, we've already established that if we fold it over the x-axis that it is not going to be symmetric. So if we were to take this and fold over the x line, it's not following along the same line, okay? But if we fold this over the y-axis, you see this right-hand side will directly align with that left-hand side. So we know that it's going to be symmetric, okay? And then the same thing with the origin. You'd flip down, and then you could flip to the right or to the left. And in this case, that would not work, okay? Now let's go on to example 2. So for example 2, we want to test x squared plus y to the 4th is equal to 5. Okay, and we're doing the same thing. We want to test for symmetry with respect to the x-axis, the y-axis, and the origin. Okay, so if we do the x-axis, that means we're going to be changing all of our y's to negative y's. There goes my dog, y'all hear her? Okay, so when we plug in this y, we want to write negative y to the 4th is equal to 5, okay? Now remember, whenever you have a negative raised to an even number, it's always going to come out even, okay? So if this was to the 3rd, then it would be negative y 3rd. So just remember that. So since this is even, this is going to become a positive, okay? So this will spit out as a positive y to the 4th is equal to 5. So are these two things the same? Yes, they are, okay? So this one would be symmetric with respect to the x-axis. Now let's do the y-axis. For the y-axis, we will be changing all of our x's in the original equation to negative x. And then everything else will stay the same, okay? Since it's an even, it's going to become a positive. And we can already tell that it will be symmetric with respect to the y-axis. And last, we check the origin. Can anyone guess what this one's going to be? Because we've already checked with y and our x, right? So we're going to change all of our x's to negative x and all of our y's to negative y in the original equation, right? And then simplify because it's even, it's going to become a positive, and same thing here. So is this the same as the original equation? It is, okay? So this one too is going to be symmetric with respect to the origin. All right. So now we're going to do one more definition. And it's going to be even and odd functions, okay? So we have even functions. And this is basically denoted as f of x equal to f of negative x. So if we're looking at this, what's the difference between the left-hand side and the right-hand side? The only thing that's changed is our x became our negative x, right? So this is also going to be symmetric with respect to the y-axis, okay? So symmetric with respect to the y-axis, okay? So if it's symmetric with respect to the y-axis, it's also going to be an even function, okay? And now we also have odd functions, okay? And our odd functions are a little bit different. So this is when we're going to have f of negative x, and it's going to be equal to negative f of x, okay? So this one looks a little strange. And this one's going to be symmetric with respect to the origin, okay? So symmetric with respect to the origin. All right, so those are our two definitions, even and odd. So for even, think about respect with the y-axis. You change your x to negative x. And for the odd, it's going to be a little mixture of both, right? So when our x is negative, it becomes positive. And when our y, which is f of x, is positive, then the y over here becomes negative, okay? So let's look at an example. We're going to be doing example 3. And we want to determine whether it's even, odd, or neither, okay? So even, odd, or neither. For the first one, A, we'll have f of x is equal to 5x to the 7 minus 6x to the 3rd minus 2x. So this is the first one. Right, so we're going to check whether it is, I guess we can do both of them at the same time, right? Because we're going to be plugging in a negative x. Makes sense, right? Okay, so let's plug in a negative x instead of a positive x and see what happens, okay? So everywhere there's an x, I'm going to plug in negative x, okay? And then I'm going to simplify this. So this is going to be 5, and because this is an odd, it's going to become a negative, okay? So this is going to be negative 5x to the 7. Okay, we already have a minus 6 here. And then again, because this is odd, it's going to become a negative. So that's going to make this turn into a positive, okay? So just to repeat, because this is odd, it's going to be negative 5. Because this is odd, it's going to be negative, but we already have a negative 6, so it becomes a positive. Okay, and we have x to the 3rd. And then negative 2 times negative x is going to give us another positive 2 to the x, okay? So to check whether or not something is even or not, we have these written right here. Right, so to be even, f of x and f of negative x, which is here and here, have to be equal. So the question is this the same thing as this? No, they're not, okay? So this is not even. Okay? And now we need to check for odd, okay? So for the odd, we have to check f of negative x, which we already have, right? And then we need to check if that's going to be the same thing as negative f of x, okay? So I'm going to do negative f of x, okay? So that means everywhere, since I just changed this whole left-hand side to a negative, I'm going to do that to the entire right-hand side as well. And I'm just going to rewrite the original equation. So it's going to be 5x to the 7 minus 6x to the 3rd minus 2x, okay? So all I've done was multiply both the left-hand side and the right-hand side by a negative. And then I need to distribute that negative to each of my parts, okay? So this is going to be equal to negative 5x to the 7 plus 6x to the 3rd plus 2x, okay? So to determine whether it is odd, we need to take our our f of negative x, which is here, and compare it to our negative f of x, which is here. And we want to know if they're the same. Are they? Yeah, okay. So that means that this is even. Excuse me, this is odd. We've already done even. Okay, so this is an odd function. Perfect. And part B, let's look at h of x equal to 5x to the 6 minus 3x squared minus 7. Okay, and we want to check whether it is even, odd, or neither. Okay, and this is the problem that I want you guys to do on your own and turn it in during class.